Hi there. Welcome to this lesson on Pure Mathematics 1. We're on chapter 3, and in this lesson we're looking at linear inequalities. Now, the first thing to be said about certainly basic inequalities, you can use exactly the same techniques as you would use for solving an equation. Now, there is one very important case when you can't do that, but in general, the techniques that work for normal equations, they still work for inequalities. You've just got to change the sign from equals to less than or greater than. So for example, if you had a simple linear equation, 2x minus 8 equals 4, you'd add 8 to both sides and get 2x is 12. Dividing by 2 would give you x equals 6. If you have the inequality that looks a lot more complicated, it isn't. You just use exactly the same method. Add 8 to both sides, you get 2x is less than or equal to 12, divide by 2, and that is the answer. X is less than or equal to 6. So we use the same approach, the same techniques. However, there is one case where that wouldn't work so well. Now, if you had the equation minus 4x equals 20, one way to do this, the quickest way probably, is divide by minus 4. So you get x equals 20 divided by minus 4, and x equals minus 5 is the correct answer. There's a problem if you change that to an inequality. So let's say you had the inequality minus 4x is less than 20. I'll let you have a go at this first and see if you can work out what the problem is. So pause the video and come back to me when you're ready. Okay, well, I'll start off just by pretending that I don't know there's a problem and just press forwards as we did above. Divide by minus 4, you get x is less than 20 divided by minus 4. And that will give you x is less than minus 5, which unfortunately is the wrong answer. There is only one time when you can't use exactly the same method as you do with equations, and it's when we do what we've done here. If you multiply or divide by a negative number, you have to swap to the opposite inequality sign. So here we divided by minus 4. That's where the problem is. If you ever divide or multiply an inequality by a negative number, the inequality sign has to change over. So the way we should have done this, if we were going to divide by minus 4, you can do, but you have to walk very carefully. So when you divide by minus 4, the less than swaps to greater than, and you get x is greater than 20 divided by minus 4. And then the correct answer is x is greater than minus 5. So dividing or multiplying by a negative number, the inequality sign has to swap like we did there. However, it's never necessary to do that. It is always possible to avoid multiplying or dividing by a negative number. And in general, that's what I do. Rather than create any confusion, I choose to find another way to do the question. So coming back to this question, minus 4x is less than 20. One thing we could do, which feels like a waste of time, is just swap sides. So add 4x to both sides, take away 20 from both sides. The two things swap sides effectively, and we get minus 20 is less than 4x. There's no problem doing that. We were just adding or taking away. Now when we move the 4 across, we're dividing by plus 4. And dividing by a positive is fine. There's no issues there. So I'd probably do that first, just to make it look normal with the x's on the left-hand side. So minus 20 is less than 4x. Same thing as 4x is greater than minus 20. Then dividing by plus 4, you get x is greater than minus 5, which was the correct answer that we got before. So you have a choice. You can multiply or divide by a negative number, but remember to change the sign if you do. Or if you remember that there's an issue, you can always look for a method which doesn't require you to multiply or divide by a negative number. Okay, 3 questions for you to have a go at yourselves. Pause the video and come back to me when you're ready. Okay, let's have a look at these. So the first question, 4x plus 3 is greater than 2x plus 6. Everything here is normal. We'll just use the same method as we would if it was an equation. So the 2x moves over, the 3 moves over, and that gives you 2x is bigger than 3. Then the 2 swap sides, we divide by it, and we get x is greater than 1.5. And that's it done. That is the answer. X has to be bigger than 1.5 for this to be true. Second question, minus 5x is less than or equal to 30. Well, this is like the case we looked at just now. The dangerous thing is dividing by minus 5. I'll choose not to do that. I'll just swap sides with everything. So adding 30, or adding 5x rather to both sides and taking away 30 from both sides would give me that. Then I can divide by the 5. And before I divide by the 5, no, we'll do that first. So dividing by 5, that gives you minus 6 is less than or equal to x. It's more normal to write that the other way around. So at some point, I would always rearrange this, just so that the x is on the left-hand side rather than the right-hand side. When you do that, be careful. The sign will have to swap. So that says x is bigger than or equal to minus 6. So does this. Third question, we multiply the brackets in the normal way. And that will give us 8x minus 12 plus 5 is greater than or equal to 6x plus 14. We collect terms in the normal way. That gives us 2x is greater than or equal to 21. And then we divide by 2, which gives us the answer. X has to be greater than or equal to 10.5. When we have two inequalities that are combined together, a number line can be useful. It's not essential, unless in the question they make it essential and say that you have to draw one. We'll do an example together just so it's clear exactly what I'm talking about. This example, draw on a number line, x is bigger than minus 5 and x is less than or equal to 1. Then draw and write the set of numbers for which both inequalities are true. So starting with the first one, x is greater than minus 5. This is what I mean by a number line, and then drawing underneath it the inequality. So it's just a normal number line starting at minus 9 in this case and going upwards. This says x has to be bigger than minus 5, so the line starts at minus 5, keeps on going up. The arrow on the end indicates that it's going to keep on going forever. So you put an arrow on if you really mean the line just carries on and on. Now in this case, x isn't allowed to equal minus 5, it has got to be bigger than it. This hollow circle indicates that minus 5 is not included. If it was included, we'd do a solid circle. But a hollow circle means x has to be bigger than minus 5, so minus 5 is not on the line. Everything above it is. The second inequality was x is less than or equal to 1, so we'll do the same thing with that. It's going to start at 1, but come backwards this time. So that would be x is less than or equal to 1. Again, you get a line starting at 1. The arrow indicates it's going to head forever towards the left. This time we allow x to equal 1. So x is less than or equal to 1. That's what the solid circle shows. The solid circle indicates that 1 is allowed. X can equal 1. We were then asked to draw and write down the set of numbers for which both inequalities are true. So we'll do that. For both of them to be true, this is the stretch of line you'll get. You're looking for the bit of the line which is true for both of them, which is the bit that starts at minus 5 and finishes at 1. So that's how you draw it. Notice again, we still have the hollow circle at 5, minus 5, because minus 5 isn't allowed. Solid circle at 1 because 1 is allowed. But we're looking for the bit that's true for both, on both lines. And that's how you'd write it down. Minus 5 is less than x, is less than or equal to 1. Okay, a couple of questions for you to have a go at. Pause the video, come back to me when you're ready. Okay, we'll have a look at these together. So the first question, looking at the first inequality, 5x plus 11 is greater than or equal to 2x minus 1. Well, we need to simplify that first, so we need to tidy it up. That'll become 3x is greater than or equal to minus 12. Dividing through by the 3 gives us x is greater than or equal to minus 4. Then we can draw that on the number line. So it's going to start at minus 4, solid circle, because it can equal minus 4. Second one, 6x plus 3 is less than 2x plus 11. Just tidying that up a bit gives us 4x is less than 8, and then x is less than 2. Drawing the line for that, it'll start at 2, it'll head backwards, a hollow circle at the end because x can't actually equal 2. And the significant word here, because it is different in the other question, is the word and. Now, and is a really important question when you come to probability and statistics. In this case, and means both things must be true. So you're writing down the numbers for which both things are true. And in this case, that would be all the numbers from -4 up to 2, including -4, but not including 2 when we get there. Just to introduce you to how this is sometimes written in set language, it looks so much more confusing. It means exactly the same thing. I wouldn't choose to write the answer like this, but it is possible they would ask you to. The way you would read that, it says the set of values, same as before, is x, the 2 dots, such that. You'd read them as saying such that. So x, such that x is greater than or equal to -4, and it's the intersection of the values x such that x is less than 2. It's a much more complicated way of saying we want all the numbers that are in the first thing as long as they are in the second thing as well. It's the intersection of those two sets. But as I say, if it was my choice, that's how I'd write down the answer. So unless they ask you to use set language, I wouldn't choose to. This is much, much easier to read and understand. Now the second question, the word or is in the middle. Now we'll come to that in a moment, but it does matter. The word or does mean something different. But first of all, 7x plus 11 is less than or equal to 3x minus 9. Tidying that up gives us 4x is less than or equal to minus 20. And tidying that gives us x is less than or equal to minus 5. Drawing it, that's what we will have. It'll start at minus 5 and head backwards. Solid circle because it can equal minus 5. The second one, that's what we've got in the question. Tidying that up will give us 2x is greater than or equal to minus 4, which means x is greater than or equal to minus 2. The line for that will start at minus 2 and head towards the right. Again, it's solid circle because it can equal minus 2. Now we come to the word or. What the word or is saying is, well, either this first statement can be true, or this second statement can be true. We don't mind which. Include all the answers from the first one and join them together with all the answers from the second one. So just include the whole lot, which in set language is what's meant by union, where you combine things together and you say either the first thing can be true or the second thing can be true, or both can be true. We really don't mind, but you just combine everything. So that is what the combined answer would look like. You just have both lines combined together. And the way you would write that down is that the set of values is x is less than or equal to minus 5 or x is less than or equal to minus 2. Either of those things is fine. Writing it in set language, that is what you would have. The set of values is x such that x is less than or equal to minus 5. Union is what that symbol is. Union x such that x is greater than or equal to minus 2. And what the union means is just combine the values together. Include the first lot, include the second lot, just add them all together, include them all. Okay, that gets us to the end of this lesson. If you have the textbook, turn to page 45 and have a go at exercise 3D. Thank you very much for listening and cheerio.